So, good morning everyone. Let's move on to class. Can you see my screen?
Yes, sir.
Okay. So, if Docker is completed, so let's move on to Kubernetes. Very, very important. And interview also, real time also, most of the people nowadays, organizations they are using. So, what is Kubernetes and how it will work? Now, go to here. So now, as of now, right, Docker. As of now, so Docker, in Docker, so what is Docker? So Docker is a containerized architecture. With the help of Docker, we can deploy our application within the container form. Within the container form. Right, what is difference between so VM machines, virtual and Docker, and what is the advantage of Docker and why should we go for Docker and all. And the same way, so if you have only Docker as of now, for example, I have application, right? Now see here, this is application. For example, Java application I deployed it. I created Tomcat container. I created Tomcat container. I created Tomcat container. I deployed my application, correct? Tomcat container. Just assume Tomcat container. And so here I deployed Java application, Java web application. Okay, Java application. So unfortunately, if container is deleted, if container is deleted, again who is creating? Just assume real time, this is the organization. I created one container, and so this is my application, this is my Windows, this is our org, and so here I created one container. In the container I create, this is the operating system. On top of, right, we are creating multiple containers. So I configure everything, and my container is running. So unfortunately, the container is deleted as of now. If మీకు డాకర్ తెలుసు కదా, సో డాకర్ నాలెడ్జ్ ప్రకారం సపోజ్ ఇఫ్ యూ delete this container, again who is creating?
Madam
Manually
create.
we are creating, right? But real time, we don't know when it will go to delete, who deleted. Maybe some reason the container is deleted. So obviously, right, application down, right? If container is deleted means, can you access your application? No, right?
Yes.
So application downtime. Again we are go, again we are going, and again we are going, and again we are going, and we are creating container manually. We are creating container manually. Got it? But so real time, if you, if it is happening like this, obviously this is downtime, right? We don't know when this container is deleted. We cannot search, we cannot check every time, right, whether that container is running or not, and this is health stated or not. So if you come to real time, this is very difficult to handle. That is not only single container. If you come to real time, there is multiple containers running, Java related, .NET related. There is each multiple projects running. For every project, we have one container, and we can access. We are able to access our application. Unfortunately, this container is deleted. As of now, you don't know how to handle it. But this is a downtime. So how to scale up and how to scale down automatically. For example, even container is deleted. So now container is deleted. As of now, we are creating manually. You know how to create manually. Again, container is up and running. Now we can able to access your application. But if you come to real time, there is number of containers running, number of application deployed. We don't know which container deleted. That is very difficult to handle, right? But how to handle this situation? So that case, you should go for, there is one more concept, advanced. So there is a Docker swarm also is there. Docker swarm. So these all are after what is happening? delete అయింది. Someone is okay. Now can you see my screen? Hello? Delete disconnect అయింది. Visible or not? Yes, Ramya. Can you see on screen? Hello? Screen కనిపిస్తుందా లేదా? I don't know. Hemant, visible? Hello? My screen is visible or not? I don't know. What Haripriya? Visible? Okay, okay. Hello? I am audible now?
Hello.
Yeah, yeah.
Yes, yes.
Okay, okay. So now see here. This is the our application. I created one container. I created one container and application is running. So unfortunately, by mistake, so container is deleted. So as of now, we are creating manually, right? But if we come to real time, so creating manually, that is very headache. We don't know which container is deleted. We don't know which application is running. So that is very difficult. So but how to handle? So for this, so there is a few more tools also is there. As of now, Docker. There is Docker Swarm also is there. See here, Docker Swarm. Just remember, but no one is asking intervals. See here, Docker Swarm. So this is Swarm also. This is mode advanced features managing cluster of Docker demands. So as of now, we know Docker, and so compared to Docker, this is Docker Swarm also advanced feature. There is some extra features. So it is following master and worker node. Master, that is the master, that is the manager and worker node. Like this we are menu. There is a one master is there. There is a one manager, and so we are maintaining so multiple clusters, multiple nodes. We are maintaining same architecture. It is following, and most of the people we are not going to use this one also. This is also updated. So these are the nodes, and within the nodes we are going to create a multiple containers. So just remember what is Docker. This is the Swarm and how it will work. If enter one or two people, they asked what is Docker Swarm. Docker Swarm is also same container orchestration tool for clustering and scheduling Docker containers. Docker containers. So as of now, what is Docker, and Docker Swarm, how it will work means. So this is also same container orchestration tool for clustering and scheduling your Docker containers. So Docker containers, and so if you come to here, so diagram, this is the, so it is following. So this is the following manager and worker nodes. So just to simply understand, it is following manager and worker node. So there is one manager, there is one manager. Manager can handle multiple worker nodes, multiple worker nodes. Same real time. For example, we have a project, right, in even organization. So there is one manager. Manager can handle multiple projects, right? Just assume this is the manager, and the manager can handle multiple projects, correct? So for every project, multiple peoples are working. Got it? Same way. So it is following a manager and worker node architecture. It is following one manager and so multiple worker node architecture. Here terminologies, this is the manager and these are the worker nodes. And each worker nodes we are going to create multiple containers and every worker nodes. This and all taking care by who? Only manager. This is the container. This is the worker nodes. This is the manager. It is following worker node. Anyway, we are going to learn Kubernetes, right? Kubernetes also following same architecture. We can easily understand. So we can easily understand. So we can easily understand. If anyone is asking, so what is? So what is a Docker Swarm and how it will work? So Docker Swarm means this is also container orchestration tool, and so with the help of we can create a cluster and we can scheduling your Docker containers. So most of the people, so we are using old days. After Docker, we are using Docker Swarm only. We are using Docker Swarm only. Now see here. So this is the same. This this. Now see here. This is the hardware devices, and this is the right operating system, and this is the Docker engine. On top of we are going to configure operating system and configure your whatever necessary, and we are going to deploy your application. We are going to deploy your application. Just to go through it, we can easily understand. Anyway, we are going to learn Kubernetes, right? This is the advanced one, and so these all are including so Docker Swarm only. Docker Swarm advanced concept, Kubernetes only. So there is many features available, and interview if anyone is asking, so just remember what is Docker Swarm. Docker Swarm also, this is the orchestration tool for creating cluster and scheduling your containers, scheduling your containers. Okay. Now, so advanced, this is after Docker Swarm, right? After Docker Swarm, so now we are using so Kubernetes. Simply we are calling K8s also, and most of the people they are asking Kubernetes or K8s. Kubernetes or K8s. So this is also open source. This is also open source. And so what are the main components and how it will work? We'll see. Got it? So this is the Kubernetes. Current mostly people are using this one only. This is also following master and worker node architecture, and we'll see one by one how it will work. This is the official document. If you want to, we can go through this official document how it will work. Now, so while discussing Docker, right? So I shown one diagram. Now come to same that one only. So Docker here, right? Now if you go here first, now see here. Already you know what is traditional deployment, and so how it will work, and what is virtual VM missions, how to create, how it will work, VM missions, on top of how we are going to configure our operating systems, how we are going to deploy our application. So to overcome this problem, now we move on to Docker, right? So Docker, this is the container deployment. This is the container deployment. Same story, hardware devices, operating system. This is our main operating system. On top of we are going to we are going to install Docker. On top of we are going to create multiple containers. Got it? So if you have only one Docker engine, if you have only one Docker daemon, so this is enough. Containers, Docker containers is enough. Suppose if you want to handle multiple Dockers, I want to handle multiple Dockers, multiple daemons. So that case we go for Kubernetes deployment. Now see here Kubernetes. So see here how it will work. Simply, if you want to understand, if you want to handle multiple Dockers, simply you go for so K8s. So people are calling K8s or Kubernetes. K8s means in K and S in between we have 8 characters. Simply they are calling K8s. K8s. So if anyone is asking what is K8s, or if they are asking Kubernetes, both are same only. Don't confuse here. Don't confuse here. Now see here, Kubernetes plus Docker work together to build run containers application. And so Kubernetes also mostly we are using Docker. Without Docker there is no Kubernetes. Now got it? See here, Kubernetes and Docker work together to build and run your applications, to run your containerized application. Containerized application. So simply understand. So if you want to handle multiple Dockers and multiple containers, and there is a lot of features available here. Okay, so suppose in Docker we cannot create, if you want to create container manually we have to create container, right? But if you come to Kubernetes, so automatically it will create container, even container is deleted. There is a lot of features available in Kubernetes. Now we'll see one by one. Got it, guys? Anyone any doubt here? So why you go for Kubernetes? Already Docker you know, and what is the disadvantages and what is the advantage and all we'll discuss here. Clear, Hemant? Hello? Got it.
Yes, sir.
Okay. Now see, simply understand. So see, this is one only. As of now, you know how to install Docker and how to handle containers. As of now, you know some basics and all. Now we are going to learn advanced. So how to handle multiple Dockers and how to create multiple containers and how to deploy multiple applications also. Okay, multiple applications also. Now, so now we'll see. So how it will work. What are the components and all. First we'll see basic. K8s. Okay. Now, so if you go here, I'll start this document. This is the Kubernetes. So they simply we are calling K8s also. Simply we are calling K8s also. K8s also. So Kubernetes or K8s both are same. See here in between we can see 8 characters. So that is the reason we are calling so K8s. Okay. Now see here. So what is Kubernetes? If anyone is asking what is Kubernetes and so how it will work and all. Now see here. So Kubernetes also same. So this is also orchestration engine. See, Kubernetes is an orchestration engine, and this is also open source platform. This is also open source platform to managing containerized application. So you know right what is containers? I hope everyone know why you go for containers. If you want to deploy application with the container form, with the containerized way, so that case you should go for Kubernetes. This is also open source. We can simply download, we can install, and we can practice. And see here it is following including container deployment, and also you can scaling and we can scale up whatever you want, so we can follow. So we can easily scale up and we can easily scale down. So as of now we discuss, right, if container is deleted, if this is the container, so this is the container. In case container is deleted, we are creating manually in container part. But if you come to Kubernetes, so we can easily scale up and we can easily scale down. Scale up means we can increase, scale down, and so descaling also. We can downgrade also. We can right, decrease that count also. And also it is maintaining load balancer. I hope everyone know what is load balancer in AWS and how it will work. You know, right? All same concepts only. AWS load balancer. So AWS load balancer, ALB, and auto scaling. You know, right? Same features here also it will available, and also load balancing. And Kubernetes is not a replacement of Docker. Now see here, Kubernetes is not a replacement of Docker, but Kubernetes can consider as replacement of Docker Swarm. Now we know what is Docker Swarm. Docker Swarm is also, this is a containerization tool, and Docker Swarm follow right. So manager and worker node architecture, and same form, same pattern, same structure here also we are following. So actually Kubernetes is the replacement of Docker Swarm only, not Docker. And Kubernetes is significantly more complex than Docker Swarm and require more work to deploy. And if you want to work with Docker Swarm and just to Google it, how architecture, what is the components, all we can easily understand. Now anyway, in Kubernetes we are learning, right? Everything we can cover here. And so this and all basic for your understanding purpose. It is firstly, right. So the Kubernetes is introduced 2014, and first version is V1 version 1.0, and this is the July 21, and the current version is not this one. This is the old one only. Now current Kubernetes version is V1 V1.29. I think every 3 months or 6 months it is updating. Current Kubernetes version, current Kubernetes version V1.29. See 30 also they released. See 29, 28, 30. So this is the old. That time it is 18. Now the current version is so these are the latest versions, 29, 28, 30. See Kubernetes is the new version 1.9, 19, 20. So see here when they released. So 1 week and 3 days ago, April 17, they released 1.30, and so this is the 8 months ago 1.28, 4 months ago 1.29. So like this, so every 3 months, every 4 months, they are releasing new versions and all. And the latest version is 1.30, 1.30. But mostly we are going to work with 1.28 or 27. Mostly we are going to work with so 1.2728. In real time also mostly we are using this one only. We are not going to use latest one because in latest one there is some issues. They are adding some features, right? Maybe might be that features working properly or not working properly. So that is the reason mostly we are using so bit older only, older versions. See here. So if anyone is asking, so currently which version you are using means just we can say 1.28 or 1.27. There is many versions available. Suppose if you are using old means we are using old means that case we can use. See, this is 1 year ago. They released 1.27. This is 8 months ago. Or if you want to more release, we can say whatever you want. So these are the 3 years ago, whichever what are the features and what they added. This is also ends tomorrow, 28 April. And so see, 8 months ago ends with 4 months. Just we can update whatever we want, we can use it. These are the current versions. Now, if you go here, now see here. So this is the current stable version is V1 1.28. We can say or 27 or 29. Now, so these are the some of the features, how it will work. You know, right? What are the Docker features? How to create Docker? How much time it will take? And it is taking less space and boot up time very less. You know, few points. Same way, these are the Docker features. See here, automated scheduling and self-healing compatibilities, automated rollout and rollback, and horizontal scaling and load balancer. These are the some major, the main advantages. Anyway, we'll discuss later. First, we'll come to how it will work. See here, we'll see later this one. What is the feature? You don't know, right? How it will work and all. We'll see. Now, see here, in interview also most of the people they are asking this question. Can you explain Kubernetes architecture or can you explain? So what are the main components in Kubernetes? Now see here, this is the architecture. Most of the people they are expecting this one. So they are expecting this one. Most of the people they are expecting so this one only. So Kubernetes. See, Kubernetes implements a cluster computing background. Everything works from the Kubernetes cluster. This cluster is hosted by one node acting as master and remaining all are working as the worker nodes. Worker nodes. Simply, this is the same architecture. Now, if you see here, now this is the master. Now one is acting as, so first we are going to select so 3 4 missions same. So this is the all are same only. For example, here I selected so 4 Linux servers or Ubuntu servers 3 4 and one mission only I am going to make it as master. So anything that is your wish. One mission only it is acting as master and remaining all are working as worker nodes. So Kubernetes following master and worker node architecture. Master and this is the master. This is the master. This is the master. This is also same mission. Don't confuse here. This is also one mission. This is also one operating system. Okay. So this is the worker node. This is the worker node. Worker worker node. For example, this is the worker node 1 and so or node 1 node 2 anyone, sometimes I am calling worker node 1 or node 1 node 2 also worker. This is the node 2 and this is the node 3. Node 3. Now this is the master. Master means only this mission handling these worker nodes. This mission only handling these worker nodes. And how it will work means like this. See here. So Kubernetes implements same. This is the master. One mission is a make as master and remaining all are worker nodes. Remaining all are worker nodes only. Now, if you see here, more if they are asking any questions in Kubernetes means first they are asking this question only. Can you explain Kubernetes architecture or can you explain what are the major components in Kubernetes? What are the major components in Kubernetes? Now see here, this is the master and this is the worker nodes. Now, if you come to master, so here mostly there is right 4 components. So they are expecting so 4 components. One is API server, one is API server, and so ET, CD, and this is the controller. One is controller, and second one is scheduler. So these are the major components in master. So these are the major components in master. Now see here, this is the API server and scheduler, controller and etcd. These are the main components. And if you come to worker nodes, these all are the mission, guys. Don't confuse here. This is also one operating system. This is also one operating system. This is also one operating system. Here I took a total four missions, and one mission I make it as master. Remaining three are worker nodes. అర్థమైందా? ఒక్క మిషన్ మాత్రం నేను ఏం చేశాను, మాస్టర్గా కాన్ఫిగర్ చేస్తాను. రిమైనింగ్ ఆల్ ఆర్ వర్కర్ నోట్స్. సో దీస్ వర్కర్ నోట్స్ హ్యాండిల్ బై మాస్టర్ ఓన్లీ. సేమ్ మేనేజర్, వర్కర్స్, రైట్? మేనేజర్ ఏం చేస్తాడు, వర్కర్స్ని హ్యాండిల్ చేస్తాడు, ఎవరెవరు ఎలా వర్క్ చేస్తున్నారు, సేమ్. So same thing anamata. Now see here, if you come to master, these are the main components. These are the new terminology. Try to understand. So API server, scheduler, control manager, and etcd. Now if you come to worker nodes, every worker node same some components. Every worker nodes we have some components. Now see here, this is the Docker, kubelet, kubeproxy, pods. First try to understand. So see here, this is the pod and also Docker. Next, kubelet. Next, kubeproxy. So these are in every worker node. These are the same. These are the these are the same components available every. If you go here, this worker node also, we can see this many. If you go here, here also we can see same components. We can see same components. What is happening here? Also same pod, Docker, kubelet, and kubeproxy. See here, here also same. In every worker node, same components. Now see here, so there is a parts Docker, kubelet, kubeproxy. Anyone any doubt as of now? No, it will work. Here also parts Docker, very important, kubeproxy. So in every worker node, these are the main components. Parts Docker, kubelet, and kubeproxy. So this is a master. If we come to master, these are the main components: API server, etcd, controller. This is the controller. This is the same controller, manager, and this is the scheduler. And see here, now we got it, right? This is the master. One is master, and this master handling, these are the worker nodes. In master, these are the major components. If we come to worker nodes, these are the major components. So parts we can see Docker, kubelet, kubeproxy. And for example, right, so Docker, right, Docker architecture, Docker client, Docker daemon, registry, right, what is this, why images, containers. So that is the Docker. But same way, if you come to Kubernetes, for example, here two ways we can communicate, right? In Docker client means end user. If we execute any command, I am the client, Docker client, and that command goes to who will receive that command, who will receive that request, Docker la. Docker la in a command execute Docker client interact with Docker client. So first goes to whom, ఎవరికి వెళ్తుంది రిక్వెస్ట్,
Docker,
డాకర్ డీమాన్, రైట్?
Docker
Daemon.
Daemon.
Same
Yes.
way. So that is Docker architecture. Now if you come to here Kubernetes, this is the master. In master we have four components. Just remember, try to understand this terminology. That's it. Anyway, slowly we can understand what is this, all this and all. So Kubernetes following master and worker node architecture. In master we have four components: API server, etcd, controller, scheduler. And if we come to worker nodes, every worker node has, these are the major components: pods, Docker, kubelet, kubeproxy. Now anyway, we are going to discuss all these things one by one. Now here, if you want to connect with master, master means for example, so this is a manager. Two ways we are communicate with master, manager. This is the master. In Docker Swarm, we are calling manager. Here master. That's it. So we can communicate, we can connect with CLI or we can connect with GUI. This is the CLI. You know, right? What is CLI? Command line interface. We can execute via CLI, command line interface, or we can connect with the UI, user interface also. UI. That is nothing but GUI. Same story. UI, user interface. Graphical user interface. We can connect with, so CLI means here mostly we are using, we need to install one software. Uh, we are going to install one, so this is the kubectl. Kubectl is the one package. With the help of kubectl only we are connecting kubectl controller. This is the kubectl. With the help of kubectl we can connect with master or we can connect with UI also. This is the request, whether we can connect a command prompt or whether we can connect a GUI. For example, so if I send any request, if I send any request, the first request go to whom? Master only. Like a front desk, right? So this is the master. In master we have four components. Now see here, these are the four components. So API server, scheduler, controller, etcd. Now this is the user interface. User means a GUI, whether we can communicate with via GUI or whether we can communicate via CLI also, command line interface. So these are the major components. Now every component there is some role it is handling. Now come to here, see here what is a GUI, that is the user dashboard. So dashboard is the web-based Kubernetes user interface. A GUI means, right, with the help of mouse we can handle. CLI means only command line interface. Command line configuration tool, command line configuration tool for Kubernetes used to interact with the master node of the Kubernetes. If you want to connect with master, we can execute two ways. Whether we can connect execute command via CLI or whether we can execute command via UI, user interface. That is your wish. Kubectl has the config file called kubeconfig. This file is information about the server and authentication. So here there is a one file is there. There is a one file is there. We'll see later. What is that file name? Kubeconfig file. Kubeconfig file. What this file contains? This file contains entire information. If you go any interview, right? If you go any interview or if you go any office, okay, MNC. So there is one front desk, right? Front desk. If you go to front desk, first they are asking, they are maintaining one registry, one book. They are maintaining one registry, one book. So which purpose you came here? Whom do you want to meet? So they are asking some information, basic information, phone number, time, entry time, exit time, phone number, మీరు ఎవరిని మీట్ అవ్వాలి, వాట్ ఈస్ ద పర్పస్, దట్ ఈస్ రైట్. సేమ్ థింగ్ here also we are, there is one file kube config file, and this file has the information about the server and authentication information to access the API server. సో ఈ API server మనం కనెక్ట్ అవ్వాలంటే, సో దర్ ఈస్ వన్ ఫైల్ kube config file. This file has entire information. This file has so information server about the server and authentication and information how API server, this related information and all we are maintaining this one. Anyway, if we install Kubernetes, we can see this file, otherwise we can't see. We'll see later. Now simply blindly understand, we can connect two ways. If you want to connect master, we can connect two ways, whether we can connect CLI or whether we can connect GUI, graphical user interface. Now these are the major components. Now if you come to here, now, so this is a master node, right? So this is a master node. These all are the worker nodes. These all are the worker nodes. So we can create multiple worker nodes. One manager, multiple employees, right? Same way, one master node, under one master we can configure multiple worker nodes. How many you want, that is based on your requirement, based on client requirement, based on your project, right? So bandwidth. So we are going to create multiple, we are going to create multiple worker nodes. We are going to create multiple worker nodes. Now come to here, see here, master node is responsible for managing Kubernetes cluster. So master node. So this is the master, right? So master is the responsible for managing your Kubernetes cluster. Cluster is nothing but group of servers. Don't confuse here. Kubernetes cluster is nothing but what is made a group of servers. Group of servers. So ఈ సర్వర్స్ మొత్తాన్ని హ్యాండిల్ చేసేది ఎవరు? మాస్టర్ ఓన్లీ. Now see here, responsible for the management of the Kubernetes cluster. It is mainly the entry point all administrative task. It handling the orchestration of worker nodes there, and so there can be more than one master node in the cluster. Check for the fault tolerance. Suppose if you want, we can maintain, okay, one more master also, one more master also. Now got it? So as of now we are discussing one master multiple worker nodes. If really needed, we can maintain two masters also, two masters also, two masters, two managers also. Every each project we can maintain two managers also. See here, that is also possible. See, for check for the fault tolerance, if this master goes down, who is handling these worker nodes? You know, right? అర్థమవుతుందా? ఇన్ కేస్ దిస్ మాస్టర్ నోడ్ నాట్ వర్కింగ్, దిస్ మాస్టర్ నోడ్ గోస్ డౌన్, who is handling these worker nodes? We can maintain one more master also, one more master also. But usually we are maintaining only one master multiple worker nodes. And so in case if we need, we can create a more than one master also, more than one master also. Okay, just remember. Now, so here these are the components, right? These are the components. So API server. API server means this is the like front desk. So if any, just assume API server is means this is like front desk. This is like front desk. Now see here, API server interact with the API, and it is front end of the Kubernetes control plane. It is the front end of the Kubernetes controller. And so communicate center for developers, system administrator, and any other Kubernetes components. If you want to connect any Kubernetes components, if you want to connect any Kubernetes components, first who need to contact? Only API server. మన ఆఫీస్లో ఎంటర్ అవ్వాలంటే ఫస్ట్ ఏం చేయాలి? ఫ్రంట్ డెస్క్లో ఎంట్రీ అయిన తర్వాతనే నెక్స్ట్ వేర్ ఎవర్ యూ వాంట్ టు గో. అర్థమవుతుందా? దిస్ ఈజ్ లైక్ ఫ్రంట్ డెస్క్. API server. API server is nothing but a front desk. Even if I go to my office, there is one front desk. So they are entering my employee ID, my laptop serial number, and so whether it is IT, non-IT, and what is the in time, what is the out time, and what are the components I am taking. So they are entering each and everything. So this is like front desk. See, API server is simply nothing but front desk. And so communication center for developers or system administrators or anything. If you can, if you want to communicate with any others, first you need to go to API server only. API server simply it will receive your request. It receive your request only. Got it? Anyone any doubt here? What is API? So this is like it is acting as a front desk. If you want to communicate with any other Kubernetes components, first request go to whom? First request received whom? Only API server. API server is like front desk. Once it will go to request API server, API server knows. If ఫ్రంట్ డెస్క్ వాళ్ళు తెలుసు, వాళ్ళకి నువ్వు ఎవరు మీట్ అవ్వాలి, ఏ మేనేజర్ మీట్ అవ్వాలంటే వాళ్ళకి ఫోన్ చేస్తారు. ఓకే, సో దిస్ పర్సన్ coming to interview purpose, so they are asking the managers, they are intimate to manager, and they will call after some time. So same like API server, this is like front desk. And see here, what is a scheduler, and there is etcd. See here, etcd is the simple distributed key and value store like db. So ఈ ఫ్రంట్ డెస్క్ పీపుల్ ఏం చేస్తారు, ఒక రిజిస్టర్ మెయింటైన్ చేస్తారు కదా, మల్టిపుల్ కాలమ్స్ ఉంటాయి, మల్టిపుల్ కాలమ్స్, కరెక్ట్. సో ఒక కాలంలో సీరియల్ నెంబరు, ఒక కాలంలో నేమ్, ఇంకో కాలంలో ఇన్ టైమ్, ఇంకో కాలంలో అవుట్ టైమ్, అండ్ వాట్ ఈస్ ద ల్యాప్టాప్ సీరియల్ నెంబర్ అండ్ ట్యాగ్, వన్ కాలం ఎంప్లాయ్ ఐడి. దే ఆర్ మెయింటైనింగ్ సమ్ ఇన్ఫర్మేషన్, రైట్? సేమ్ వే హియర్ ఆల్సో దెర్ ఈస్ వన్ కాంపోనెంట్ is there, etcd. What etcd will do? So see, this is like a simple database. Etcd Kubernetes uses etcd. It's like database to store all the cluster data. సో ఈ డేటా మొత్తాన్ని ఎక్కడ మెయింటైన్ చేస్తారు వీళ్ళు? See here in this component. So API server receives the request. API server gets some information. This information and all it will store into the where etcd. Got it? Very simple. Front desk వాళ్ళు ఎలా రిజిస్టర్ మెయింటైన్ చేస్తారు? సేమ్ ప్యాటర్న్. So there is one component is there master etcd. So it is stored like a database. It is maintaining like database to store the all the cluster data. Some of the data stored in the etcd, job scheduling information, parts, state of information, everything. How it is storing data in this etcd? Key and value format. Which format? Key and value format. You know, right? What is key? Most of you know, right? Key means nothing but left side. Key and value format. So the entire data it is stored into the key and value format. Key and value format, that's it. The entire cluster information etcd API server it is maintaining, it is stored into the which component? Etcd component. Etcd component. Got it, guys? Anyone any doubt? For example, I logged in, I enter username password, name equal to, so who is the username? That information like this it will store. Now see here name. For example, I given my name, my username. For example, I given DevOps. It is stored like this only. This is the key, this is the value. I enter password. So it is meaning password. Which password you enter? Okay. So that and all it is maintaining here. Okay. So it is stored into the etcd. Etcd means like it is like a database and it is maintaining that entire cluster information, that entire cluster data only. Which format? Key and values format. Key and value format. Key and value format. Got it, guys? Anyone any doubt? So master has four components: API server, scheduler, control manager, etcd. Now we know what is API server. API server acts like front desk. Every request received only API server. That API server whichever request it is receiving, that information and all it is stored into the etcd. Which format? Key and value format, like database. It is act as like database. Okay. Anyone any doubt these two components? If you understand this entire architecture, nothing, very simple. Remaining all are commands only. Remaining only commands we are going to execute. How it will work means first you need to try to understand, try to digest, and how each components, what is the role of each component. I hope you got some idea, right? What is API server? What is etcd? Anyone any doubt here? Clear? Yes or no?
Yes,
Okay.
yes, yes.
Now come to here. So now you know it is now see here scheduler. Schedule means right? Schedule watches the parts. So and assign the parts to run on the specific host machine where you want to run. So this is the scheduler. And before scheduling, what is the control manager? There is many controllers is there. We'll see. What is controller? Scheduling means scheduler watches parts. Here we have parts, right? Every worker node has parts. What it will do? Scheduler always watching the parts and assigning these parts to the specific host machine. Now మన రియల్ టైం కూర్చుంటే మేనేజ్ ఉంటారు, మనం వర్క్ చేస్తూ ఉంటాం. మనం ఐడియల్గా కూర్చున్నాం అనుకో వాళ్ళు ఒప్పుకోరు. సో ఇఫ్ యూ డోంట్ హ్యావ్ ఎనీ వర్క్, వాట్ మేనేజర్ విల్ డూ సమ్ టాస్క్. So there is some bugs or there is some defects. So they are giving some task and they are assigned into particular right, user story, particular team, like that. Same way scheduler keep on watches the parts. Part is nothing but inside part we have multiple containers. Just remember, as of now remember pod. So pod is nothing but this is the smallest runtime instance to run your application. అంటే పాడ్లో మన కంటైనర్ రన్ అవుతూ ఉంటుంది. విల్ సీ లేటర్ హౌ ఇట్ విల్ వర్క్. సో పాడ్లో మనకి ఏముంటుంది? కంటైనర్స్ ఉంటుంది. మేబీ పాడ్ కెన్ కంటైన్ మల్టిపుల్ సింగిల్ కంటైనర్ ఆర్ మల్టీ కంటైనర్స్. ఒక పార్ట్లో ఒక కంటైనర్ ఉండొచ్చు, మల్టిపుల్ కంటైనర్స్ కూడా ఉండొచ్చు. Okay, now what is the story here? It is a what is the scheduler? Scheduler means scheduler always watching the pods, and if any pod is not assigned to any worker node, so it is assigned the pod to run on specific host machine. For example, this is the one worker node, this is the one worker node. In this worker node I have many pods are running. This worker node don't have any parts. Scheduler what it will do, already these two parts, this worker nodes busy, so now what it will do, the scheduler assign that particular part to this worker node, that's it. అంటే ఎవరు ఖాళీగా ఉంటే వాళ్ళకి మూవ్ చేస్తూ ఉంటుంది, షెడ్యూల్ చేస్తూ ఉంటుంది. కీప్ ఆన్ వాచ్ ద పార్ట్స్, వాట్ ఇట్ విల్ డూ, ఇట్ విల్ కీప్ ఆన్ వాచెస్ ద పార్ట్స్ అండ్ అసైన్ ద పార్ట్స్ టు రన్ ఆన్ ద స్పెసిఫిక్ వర్కర్ నోడ్, specific host mission. So whether my pod need to work here or here and here, based on your incoming, based on your workload, automatically it is assigned to that particular worker node only. So that is nothing but schedule. Schedule means when we want to trigger, when we want to run, so that and all taking care by scheduler. Now this is the controller. Controller, you know, right, here itself we can understand what is controller. Controller means it will control, there is many controllers available here. See here, control manager, see here, control manager runs the controller in background which runs a different task in Kubernetes cluster. సో ఇక్కడ మల్టిపుల్ టాస్క్ ఎగ్జిక్యూట్ అవుతా ఉంటాయి మనకి. సో వీటి మొత్తాన్ని హ్యాండిల్ చేసేది కంట్రోలర్. నౌ సీ హియర్ హౌ ఇట్ విల్ వర్క్. పెర్ఫార్మ్స్ క్లస్టర్ లెవెల్ ఫంక్షన్స్ టైప్ రిప్లికేషన్ అండ్ కీపింగ్ ట్రాక్ ఆఫ్ వర్కర్ నోడ్ అండ్ హ్యాండ్లింగ్ నోడ్ ఫెయిల్యూర్స్, ఎవ్రీథింగ్ మొత్తాన్ని హ్యాండిల్ చేసేది కంట్రోలర్. అంటే ఈ వర్కర్ నోడ్ నాకు ప్రాపర్గా వర్క్ అవుతుందా లేదా, ఇట్ ఈజ్ వాచింగ్ అండ్ ఇట్ ఈస్ చెకింగ్ వెదర్ ఇట్ ఈస్ వర్కింగ్ ఆర్ నాట్, and this is working or not, everything it is checking anamata. So these parts are working or not, and this node is working or not, and is there any failures. So that and all taking care by only controller, that and all taking care by only controller. Now see here, there is a node controller and also replication controller, endpoint controller, replica set controller, deployment controller, daemon set controller, job controller. There is many controllers available. So if you go to controller, there is many controllers available. So each controller there is specific purpose we are using, and each controller it is taking specific right, related that work only. So for example, this is a node controller, this is a node, right, this is the worker nodes. So these three machines working properly or not, who will check this one only, node control. See, it is responsible for noticing and responding when node is go down, whether node is down or whether node is up. Who is responsible? Node controller. Node controller is the responsible for handling your nodes, that's it. Whether this node is running working or not, or whether this node goes down, or so this and all taking care by node controller. And so there is a replication controller. Replication means this is the pod, right? So pod is the smallest instance, right, and to run your application. Okay, so here there is one replication controller, it is maintaining the number of pods. What it will taking care, here also pod is there, here also pod is there, how many pods you need. Okay, so it is maintaining number of pods, it control how many identical copies of the pod should be running, whether it is every worker node. So that and all taking care by replication controller. So node controller taking only nodes, whether node is working or not, any node is goes down, so that and all taking care by node controller. Now there is a parts, how many parts you want, and all parts are running properly or not, all parts are healthy or not, so that and all taking care by replication controller, that and all taking care by replication controller. And same way there is endpoint controller, see here, and controller joins services and parts together, endpoint. So for example, so you know, right, load balancer, that load balance means distribute your incoming request to multiple machines, right? Suppose this node is not running, I don't want to distribute my request to this pod, this work node. So that case, I will remove request from endpoint, remove this endpoint, and only I want to distribute my incoming request these two machines. So like this, I hope you got it, right? So this is the endpoint. If it is working if it is working fine, I am going to do, I am sending request to this worker node also. Suppose if it is not running, I am removing endpoint this node and only send request to these two missions. That and all taking care. Now see here, replication controller. Number of replication parts are running all time. How many parts you want to run all always? And this is the deployment. This is the update, and roll back. So if you want to anything, so that case you can go for deployment controller. As of now you don't know, right? What is, you don't know what is replication controller, you don't know what is deployment object, you don't know what is replica set. So for namesake just try to understand. Anyway, coming classes we can discuss all these things. Okay. And this is the demand set. This is also all nodes run a copy of specified parts. There is a job controller. It is right, it is handling all jobs only. It is handling all jobs only. Got it? Clear, guys? Anyone any doubt? So anyway, if we are not understanding what is this and all, leave it. Coming classes will see. Just I am explaining. So there is many controllers available. One is node controller, replication controller, and so part controller, and so deployment controller, demand set controller, and jobs controller. There is many controllers. So these are the some right components. Now you know what is API and what is the purpose of API, and you know what is etcd, and etcd maintain what type of data. Now you know what is scheduler. Scheduler means keep on watches the parts and assign it to particular worker nodes. And you know what is controller. Controller means there is many controllers available. Deployment controller, replica set controller, node controller, endpoint controller, job controller. So for every controller it is taking a specific right work. It is monitoring, it is handling so that task and all. I hope you got some idea, right? Clear ma? Anyone any doubt here? These four components very very important. Interview purpose, mostly 99 not 90 100% they are asking this question. What is the purpose of API server? What is the purpose of etcd? What is the scheduler? What is the controller? I hope you got some idea. Even if you are not understanding, leave it. So next 10 days or 15 days we are discussing only Kubernetes, right? So we can easily understand all these components, how it will work. Clear? What, Hemant? Hello? Got it?
Yes, sir.
Okay.
Got it.
So that's it from my side today.